Worksheet 5.3 polynomial functions. Let's work through this. State the degree and leading coefficient of each polynomial in one variable. If it is not a polynomial in one variable, explain why. So first one, it is a polynomial in one variable. You see only one variable polynomial, and the leading degree would be x. The leading degree would be x to the 7, the highest power. The leading coefficient is the number in front of that, so negative 21. 13 has x and a y, so not in one variable. It's the only problem here. It's not one variable. And 21, they're all one variable, and the highest power is right here. So my leading degree, the highest degree of this thing is 9. My leading coefficient is the number in front of that, which is a positive 2. Find P3 for each function. So remember, there's two ways to find P3. One, you can just plug in P3. This is the fourth is 81, minus 9 times 2 is 18, plus 3. So I get negative 15, 81, minus 20 is 61, 61 plus 2, 63, 63 plus 3, 66. So that's one way to do it. The other way of doing it is do synthetic division. So I could go x to the fourth, 1, 0x cubed, so 0, negative 2x squared, 0x, and 3. Bring the first one down, 1. Since I'm using 3, let's use 3 and I'll just switch anything. 1 times 3 is 3. Add down 3, multiply across 9, add down 7, multiply across 21, 21, multiply across 63, add down 66. And the remainder will be the exact same thing. Right, so there's two ways to do this, right? If I want to find P3, one just plug it in, the other is to show you that's called a remainder theorem. You just do the remainder synthetic division. So same thing here. I'm going to do synthetic division all the way out for this one. So negative x cubed plus 3x squared. Remember, you have to go in order, so it has to be plus 0x minus 5. So negative 1. Oops. Taking up too much space there. Negative 1, 3, 0, negative 5. And what we're looking for is the remainder. That's the goal right there. Since it's P of 3, we just plug in 3. It's not a binomial, it's just letting you know it's 3, so you just use it. So bring it down, multiply across, add, multiply across, add, multiply across, negative 5. P of 3 on this one is negative 5. Over here, now they're giving you a function. So C of x equals all this, and D of x equals all that. I want you to find each value. So in the first one, all they really want us to do is plug in b squared. So what is c? C is 2 times something squared minus 4 times something plus 3. And that something we're plugging in this case is b squared. So here I get b to the fourth times 2, so 2b to the fourth minus 4b squared plus 3. That's the answer. On the next one, same idea. What is d? So d is negative x cubed plus something plus 1. Right? So remember, that's all d is. D is this guy, so take all the x's, put parentheses there. That's what d is. And then what are you plugging in? 2a. So we're plugging 2a into all of these. Now there's an extra step here, though. As you can see, there's a 5 on the outside. What does that do? Well, that's like on the outside being multiplied by all this. So outside of all this is a 5. And that's expressed. Now we just got to simplify this. Like 2a cubed. Remember that cube goes to all of it, so it becomes 2 cubed, which is 8. A cubed, and the negative on the outside, plus 2a plus 1. So we have this. Negative 8a cubed plus 2a plus 1. Multiply by 5. Should we have 5 into all of it? So I get negative 40 a cubed plus 10a plus 5. There we go. CA3. So CA3, where am I at that? So remember where C is. C is 2 times something squared minus 4 times something plus 3. And then we're going to plug in 3a. Again, squared goes to both of these, so 2 times 9a squared minus 12a plus 3. So I get 18a squared minus 12a plus 3. And the last one here, cy minus 1. So get our c back, 2 something squared minus 4 times something plus 3. And this time, we want to plug in y minus 1, y squared minus 1. So I get that. And now we just got to go through a tedious task of simplifying this. So here I'm going to get distribute negative 4y squared plus 4 plus 3. Y squared minus 1 is not to square both of them. It's a binomial. So what happens there is you got to multiply y squared minus 1 times y squared minus 1. Once you're done with that, multiply by 2. So if I did this, I would get y to the 4th minus 2y squared plus 1. All be multiplied by 2. Distribute, so I get 2y to the 4th minus 4y plus 2 minus 4y squared plus 7. I guess I could add these two up also. So that's 2y to the 4th minus 4y minus 4y squared, I should have got in front, plus 9. Oops. So that's what I get. We're kind of out of space there. Next one, it wants to match these now. So this is a little easier than look. This is probably one of the easier questions. If you have a power, if your leading coefficient is an odd power, odd degree, then your graph should go switch sides. So do something like this or something like this. If it's an even degree, it's on the same side. So something like this or like this. And then talk about the leading coefficient. If the leading coefficient is positive, then you start on the top right. If the leading coefficient is negative, it's in the bottom right. That's pretty much it. So look at our first one, 47. The leading coefficient is positive, so we're going to start on the top right. It's an odd power, so we're going to flip. So it looks something like that. And that would be D. Look at 48. The leading coefficient is negative, so I'm going to start on the bottom right. And it's an even power, so it can be the same. And that would be B. 49. The leading coefficient positive, so up, and then odd, so even, sorry, so up. So that would be A. And then right here, the leading coefficient is negative, so down to start off with, and then odd power, odd degree, sorry, so you switch. So that would be C. For each graph, describe the end behavior. So for that, all we really gotta do is say, does it look like, kind of like we just did, does it look like this, does it look like this, is it doing this? That's all I really want. So whether it represents an odd degree or even degree function. Well, you can tell by the way it looks if it's odd or even degree. Say the number of rows, zeros. So remember that's just x-intercepts. That's what rows and rows are. So A looks like this. B, it's an even function. And then C, there's 1, 2, 3, 4 row zeros. So 4 row zeros. 36, A, it's going like this and like this, right? These guys. B, that makes it an odd function because we're in opposite directions. And then C, there's only 1 row zero. That means there's lots of imaginary zeros. Just like that. Next one, it looks like this. B, it's even. And then C, there's 0 real. It's all imaginary. 0 row zeros. It's probably said no row zeros, probably better. Now the next one, 37. A, it looks like this. B, it's odd. And then C, there's only 1 again. Okay, move on to the last question. We need a calculator for it, really. Microwave manufacturing firm has determined that their profit function is this, where X is the number of microwaves sold annually. So P is profit, and X is the number of microwaves. sold. Graph the profit function in the calculator. So I don't have a calculator with me right now. I know it's an odd function, it's negative, so it's gonna look like this. So kind of do this. That might be totally off. To determine reason of view window, I need a calculator for that. Fraction all zeros of the functions of the graph calculator, so you just use your calculator to find all the zeros. What must arrange the microwave sold in order to have a profit? So in my case, from here to here, from that zero to that zero. I'm sorry, I don't have a calculator. My computer is in the shop. So that's it.